Good day everybody, we have this following question. Let me draw the semicircle. To find the area of this shaded region, this region is required. So let me highlight that. This is the region we are required to find. Okay. Right, so the information we have is this is 90 degree, this side is 2 positive root 3, this side is 3 positive root 3, and we got A, B, C. So with the information we have to go ahead. Now foremost, this is the center. Okay, this is the center O of the circle. So it's a semicircle. So what I wish to do foremost is that I would want to find out the angles. Step 1, we need to find the angles C and angle A. We know that angle B is 90 degrees. Okay, so how are we going to do that? For that, what we will do is we will find the ratio of the sides. Now I'm going to use this theorem for right triangles. If the ratio of the sides is equal to root of 3, then the angles of the right triangle will be 30, 60, 90. So let me find the ratio of 2 positive root 3 over 3 positive 2 times root 3. So I'm going to multiply, this is 2, I'm going to multiply by the conjugate. 3 negative 2 times root 3 divided by 3 negative 2 times root 3. So let us see what we are getting. So 2 positive root of 3 times 3 negative 2 times root 3 divided by, now this is of the form a positive b times a negative b, which is going to give us a squared negative b squared. So this is 3 squared negative 2 squared times 3, which is going to be 9 negative 4 times 3 is 12. Over here 2 times 3 is 6, negative 4 times root 3, and this is 3 negative 2 times root 3 into root 3 is 3. So this is 6 added with 3, and then you subtract 6 out, and then you have 4 times root 3 divided by 9 negative 12 is negative 3. Now positive 6 negative 6 goes up, so you have 3 negative 4 times root 3. So let us check if everything is rightly evaluated. Now this is actually 3 times root 3, right? So the root 3 has to be there. So we have to place this root 3 there. Okay, so this is going to give us 3 times root 3 negative 4 times root 3 divided by negative 3. So if I were to take 3 out, I will have 3 negative 4 divided by negative 3, which is going to be root of 3. 3 negative 4 is negative 1 divided by negative 3. So negative negative become positive. So you have root of 3 divided by 3. I can rewrite this 3 to be as root of 3 times root of 3. They get cancelled, giving me 1 over root 3. So we are getting the ratio as 1 over root 3, but still the rule can be applied, because instead of considering 2 positive root 3, 3 positive root 3, if you were to consider 3 positive 2 root 3 with 2 positive or 2 positive root 3, then the ratio is going to be root 3. So the conclusion is this means the angles of the triangle ABC is 30, 60, 90. Now the question is, we already have 90, so we need to allocate 30 and 60. Now the angle opposite to the smaller side, that would be taking the value 30. So this is going to be 30 degrees and this is going to be 60 degrees. Okay, so fair enough, we have got it. Okay, the next is kindly observe here, there is a point of tangency. The semicircle has a point of tangency at, say, I will mention it at P. At P. So by tangent theorem, the angle between the radius and the tangent line is 90 degrees. So if I would like to connect these 2 points, O with P, okay, this angle is going to be 90. Okay, fair enough. Now what we're going to do is we would want to get this length, right? Now this entire length is given by 3 positive 2 root 3. Okay, that's the entire length. Now what I wish to do is I would like to evaluate this portion alone. So this is the triangle we have. This is A, this is P, and this is O. This is 60 degrees, this is 90, and we have this 30 degrees. Now this is actually the radii, right? So I'm going to take this as some R. We need this OA, which is the hypotenuse. So what I would do is I will take tan 30. Tan 30 is nothing but opposite side divided by adjacent side, and my opposite side is R, the adjacent side is X. Tan 30 is nothing but 1 over root 3, right? So this is going to be equal to R over X. I can rewrite X to be equal to R times root 3. So we have got this value for X. So X is R times root 3. Now by Pythagoras, we have OP squared plus AP squared is equal to OA squared. So this is R squared plus AP squared. We need OA squared is R times root 3 squared. So from here AP squared is equal to R times R, or I would say R squared times 3 negative R squared, which is going to be R squared of 3 negative 1, which is R squared of 2. So you have 2 times R squared is equal to AP squared. So AP is equal to root of 2 times the root of R squared, which is going to be R times root 2. So this distance is R times root 2. Okay, So I hope you're able to get the idea. So now that we have got, we need to extract the value of r, right? We need the value of r. So for that, I would be using this this entire length AB. Now AB is given as 3 positive 2 times root 3. Now this distance is actually r. So 3 positive 2 times root 3, I take away r from this entire distance. I take away r, I would get the hypotenuse, right? This is the hypotenuse side. Hypotenuse would be got. Now what is the hypotenuse value? Hypotenuse value is r into root 3, right? So this is going to be r times root 3 positive r, which is going to be r of root 3 positive 1. I think I can use this side now. So this is 3 positive 2 times root 3. So therefore r is going to be 3 positive 2 times root 3 divided by root of 3 positive 1. I multiply by, in fact, okay, it does not matter. So I'll rationalize with root 3 minus 1 and divide it by root 3 minus 1. So it's going to be 3 positive 2 times root 3 times root of 3 negative 1. This is going to be 3 negative 1. I multiply 3 into root 3, 3 into negative 1, and then 2 into root 3 into root 3 is 3, and then negative 2 into root 3 divided by 3 negative 1 is 2. So this is going to give me, I can club these two together, 3 into root 3 negative 2 into root 3, and then 6 negative 3 is going to be 3 divided by 2. This I can take root 3 out, so that will give me 3 negative 2 positive 3 divided by 2, which is going to be 3 positive root 3 divided by 2 is equal to r. So this is my r. Now we have got, now if you see the figure, let me show you the figure. Okay, this is the figure. We are dealing with this figure. Now this is a sector, okay, and this is the right triangle. Okay, so if I were to reflect this, here, we are interested in this region. Okay, this region. So what is that region? That region is going to be required area is going to be area of the right triangle minus area of the sector. Okay, this will give me the required area. So let me calculate, let me get that. Okay, foremost we will find the area of the, so let me draw the figure. This is 90, this is 30, this is 60, and we have got the value of r, right? So this distance is r times root 2, this distance is r, and this distance is r into root 3. Okay, and our r value is 3 positive root 3 divided by 2, right? So if I were to take the sides A, P and O, AP is r times root 2, which is going to be 3 positive root 3 over 2 times root 2. So for the triangle, this is going to be my height, and my base, this is going to be my base. Base is going to be 3 positive root 3 over 2. So area of triangle APO is half times base times height. So half times my base is 3 positive root 3 over 2. My height is 3 positive root 3 over 2 times 2. I multiply these two. All of these is going to be 2 raised to the power of 3. This is going to be 3 positive root 3 squared, and you have a root 2 there. You expand this, you get 3 squared, 6 into root 3 plus 3 times root 2 divided by 8. So this is going to be 9 added with 3, that's 12, 6 root 3 times root 2 divided by 8. Now I can take 6 out, that will give me 2 positive root of 3 times the root of 2 divided by 8. 2 goes here 4 times, 2 goes here 3 times. So 3 root 2, 2 positive root 3 divided by 4. This is the area. Now sector, coming to the sector area. Sector area is equal to theta over 360 multiplied with pi r squared. Now this is theta, this is 60 degrees, right? So 60 over 360 pi times r squared. R is 3 positive root 3 over 2 squared. So this 6, so pi times 3 positive root of 3 squared divided by 4, right? And the 24, 6 is here, 6 times 4 is 24. So if I were to expand this, this is pi 9 positive 6 times root 3 positive 3 divided by 24. I add this, I get 12 positive 6 times root 3 divided by 24 pi. And I can take 6 out, there is 2 positive root of 3 divided by 24 pi, 4. So 2 positive root of 3 divided by 4 pi. So this is my sector area. So required region is what? Triangle, this is the area of the triangle, 3 positive root of 2 times 2 positive root of 3 divided by 4 minus 2 positive root of 3. This is pi is over here, okay, pi divided by 4. This is what we have got. So let me move to the other side. So I have 2 positive root of 3 over 4. I take out as common. So I have 3 times root 2 negative pi, okay, square units. So this is the required area. If you want, you can actually simplify this if you want, okay, to get the region. So let me use my calculator. So root 2, this is a value of root 2. I multiply by 3. I get this, and let me write that down. So this is 4.243. I take it as minus 22 over 7. What is that? Minus 3.143. Okay, and this is 2 positive root of 3 1.732 divided by 4. So 4.243 minus 3.143. This gives me 1.1, and this gives me 3.732. So I multiply with 3.732. and I divide by 4. And this is an approximate answer of 1.0263 square units. Okay, so this is the answer we got, and this is after evaluating. Thank you everybody. Please like, share and subscribe.